In this example, we've been given a circle and told that its radius is 19 and that there is a possible error in the measurement of this radius of possibly at the most 0.04 centimeters. And in the first part of the question, what we're asked to do is consider this error in the radius and use it to calculate the maximum possible error in the area of the resulting circle. But we've been asked to do this without using calculus or without using differentials in this case. So ultimately what we want to find is our change in A, our change in area, or delta A. Well, what we know is that our R1 value is 19 and that our R2 value is 19.04 because we said our change in R was 0.04. What we'll do now is find the corresponding areas to each of those radii. When the radius, or R1, is equal to 19, A1 is going to be equal to pi times 19 squared, or the area is going to be equal to 361 pi. A2, our area corresponding to our second radius, the radius 19.04, is going to be found by substituting 19.04 in for r in our formula area equals pi r squared. And when we do so, we find that A2 is equal to 362.5216 pi. That means that our change in our area, which is found by taking our A2 and subtracting A1, is going to be 1.5216 pi. If you wanted to convert this to a decimal, it would be approximately 4.7802. Well, percent error. If you take a look in your textbook, you will find that relative error and percent error are clearly defined with specific formulas, and they state that our percent error is our change in f divided by our f of a, which is then all multiplied by 100. So converting that into a notation that makes sense for this particular question, it is going to be our change in A divided by A times 100. So our change in A was 1.5216 pi. We're dividing that by our area, which should be 361 pi, and then we multiply that by 100, and what we find is that we get 0.421%. In the second part of the question, we've been asked to use differentials to work out that percent error. So we're still dealing with the formula area equals pi r squared. Our radius is 19. Our change in r, or dr, is equal to 0.04. And we are going to use dA as our approximation of delta A. We start by stating our formula for differentials. dy is equal to f prime x dx. So dA is going to be equal to 2 pi r, that's the derivative of pi r squared, times dr. We now substitute in the value of r, which is 19, and the value of dr, which is 0.04. And we find that dA is equal to 1.52 pi. You should note that this value is very close to the value of delta A that we calculated previously in part A of this question. Percent error, as defined in your textbook when you use differentials, is approximately equal to df divided by f of A times 100. So when we use the variables that are used in this question, we would say that our percent error is dA divided by A times 100. We have dA already. It's 1.52 pi. We previously calculated it. We don't have A. I know we calculated it back in part A of the question, but because we're on this screen, I'm going to show the calculation again. We substitute in 19 for R in our formula area equals pi r squared, and we find our area to be 361 pi. We substitute that back into our approximation for percent error, and we end up with our answer being 0.421%.